We talked a lot about the importance of scale interactions. Why should a forecaster always begin at the top of the funnel on the hemispheric scale?
Well, I think this sets the stage for how the synoptic weather-producing features of the atmosphere are going to react, move, or develop. Let me give you a couple good examples, and different examples. One is the very devastating Hurricane Andrew that was in 1992. If you look at the track, you'll notice that about the 21st of August, the hurricane moved sharply from a northwest track to a due westerly track. And this was the result of a larger scale motion of a trough in the westerlies moving eastward. And if you want to look at another facet of this interaction, one of the patterns you see on a satellite picture that's very significant is a leaf cloud. Now, a leaf cloud can develop into a bomb in a very, very significant storm, or it can develop into a relatively insignificant garden variety wave on a front. And the difference as to whether they develops as a bomb or an insignificant thing has to do with evaluating the large-scale features and seeing what's going on there. Another example is on a surface map, you can see storms, or low pressure centers really. And I was thinking of one that developed, it was a 1017 low, which is not very impressive. And yet within 48 hours, this was developing into a major storm with a 990 central pressure eventually. And a few months ago, I was working on a map, and here was a low about the same, 1015, something like that, millibars. And it amounted to nothing because it was essentially under a long wave ridge and didn't get any large-scale support. And so I think there's tremendous interaction, and if you know what the large scale is going to do, it helps you know what to look for and what to expect on the smaller scales.